squared is equals to 0 squared plus 2 times 0.5 times 4, which is equals to 4. Now we make square going over to the other side will now become the square root of 4, which now give us 2 meters per second. Deceleration A is equals to velocity change over time, which is equals to 25 over 10, which will give us minus 2.5 meters per second squared. Using S distance equals to ut plus half at squared. S is equals to 25 times 10 plus half times minus 25 times 10 raised to power 2 will give us 125 meters. Example 2. A motorcycle accelerates from rest for 10 seconds up to a velocity of 20 meters per second. It continues with uniform velocity for further 20 seconds and then decelerates so that it stops in 20 seconds. Calculate A. Acceleration, B. Deceleration, C. Distance traveled. Solution. Acceleration along OA is equals to velocity change over time, which is equals to gradient of OA is equals to AE over OE, which is now equal to 20 over 10, which will give us 2 meters per second. Plotting the velocity time graph using 10, 20 as an interval at the vertical axis along the velocity axis and against time at an interval of 10, 20, 30, 40. We now have the body moving from point O to A, then at a change in velocity, then it has a constant time from A to B before it decelerates from B to C at a change in velocity. Deceleration along BC. Deceleration along BC is equals to velocity over time, which is equals to the gradient of BC, which is equals to BD over DC, which is equals to 20 over 20, which will give us 1 meters per second. C. Total distance traveled is equals to the area of trapezium OABC, which is equals to half AB plus OC times AE. Total distance traveled S is equals to half in bracket 20 plus 50 times 20, which will give us 700 cm. Example 5. A train has an initial velocity of 44 meters per second and acceleration of minus 4 meters per second squared. Calculate the velocity after 10 seconds. Solution. Initial velocity U is equals to 44 meters per second. Acceleration A equals to minus 4 meters per second squared, and time T is equals to 10 seconds. Using V equals to U plus AT, we have V, and substituting the values for the first equation of motion, we have that the final velocity V is equals to 44 plus minus 4 times 10, which will now give us 44 minus 4, which will now give us 4 meters per second. Example 6. A ball is thrown vertically upward from the ground with initial velocity of 50 meters per second. A. What is the total time spent by the ball in the air? B. Calculate the highest distance reached. Solution. A. Final velocity V is equals to 0. A is equals to minus 10 meters per second squared, and initial velocity U is equals to 50 meters per second. Using our first law of equation of motion, we have that V is equals to U plus AT. Substituting the values, we now have 0 equals to 50 plus in bracket minus 10 times t. Making t the subject of the formula, we now have 50 over 10, which now gives us 5 seconds. The distance v is equals to ut plus half at squared. Therefore, the distance s is equals to 50 times 5 minus half in bracket minus 10 times 5 raised to power 2, which now gives us 125 cm. Example 7. A particle moving in a straight line with a uniform deceleration has a velocity of 40 meters per second at its point P, 20 meters per second at a point Q, and come to rest at a point R, where QR is 50 meters. Calculate I, distance PQ, II, time taken to cover PQ, III, time taken to cover PR. Looking at this diagram, figure 1.13 example show that the the body is moving with a velocity of 40 meters per second at P. Then at point 20, it is moving with a velocity of 20 meters per second. Then when it is at R, it came to rest with 0 meters per second. Then we are given the distance from Q to R as 15 meters, and we are asked to get the distance from P to Q, and the time from P to Q, and the time from P to R. Solution. Using the third equation of uniform motion for equation between QR, V squared is equals to U squared plus 2AX. S is equals to QR, which is equals to 50 meters. U is equals to 20 meters per second. V is equals to 0. Substituting the values, we now have 0 squared is equals to 20 squared plus 2 times A times 50. 0 is equals to 400 plus 100A. Taking the unknown value to the left hand side and the known value to the right hand side, we have minus 100A is equals to 400. Then making A the subject of the formula, you have 400 over 100. We now have minus 4 meters per second. The negative sign indicates deceleration. Using the deceleration for motion between PQ, we have that distance PQ. Using the first equation of motion, we have V squared is equals to U squared plus 2AX, but U is equals to 40 meters per second, V is equals to 20 meters per second, and A is equals to minus 4 meters per second squared. Substituting the value, we have 20 squared is equals to 40 squared plus 2 times minus 4 times PQ. 400 is equals to 1600 minus 8 PQ. Putting the values at the left hand side, known values at the left hand side, and the known values at the right hand side, we have 8 PQ is equals to 1600 minus 400. 8 PQ is now equal to 1200. PQ is equals to 1200 over 8, which will give us 150 meters. II for time